In this video, we're diving deep into SAP Extended Warehouse Management, or SAP EWM, the powerful tool behind some of the world's most efficient supply chains. 1. What is SAP EWM? SAP EWM, an abbreviation for SAP Extended Warehouse Management, is a software system specifically developed by SAP to manage and optimize warehouse operations. Its primary purpose is to streamline various warehouse processes, including distribution, fulfillment, storage, and inventory management. It supports the entire warehouse logistics, managing all goods movements and warehouse management, with a focus on efficiency. Role in supply chain management. SAP EWM is part of the SAP Supply Chain Management, SAP SCM, solution package. It is integrated with SAP ERP systems to enhance the efficiency of warehouse management, order fulfillment, and transport processes. As a future-oriented software, SAP EWM, especially when integrated with SAP S/4HANA, provides the necessary capabilities for Logistics 4.0, characterized by fully automated warehouse systems. 2. Core features and functionalities of SAP EWM. SAP EWM offers a comprehensive suite of features that go beyond basic warehouse management, enabling sophisticated control and optimization of logistics processes. Inventory management. SAP EWM provides real-time visibility into inventory levels, locations, and movements, enabling accurate stock management. It supports sophisticated inventory management by tracking handling units, batches, and serial numbers. It also facilitates inventory optimization through physical inventory procedures and cycle counts, including a difference monitor with definable tolerances. Warehouse task management. It ensures the effective execution of various warehouse operations such as receiving, put away, picking, packing, and shipping. It optimizes task execution efficiency through features like task interleaving and work packages that guide warehouse employees. Slotting and storage control. This feature identifies the optimal places to store products based on criteria such as demand, size, weight, and turnover frequency, thereby optimizing space utilization. It supports multi-level storage capabilities and adaptable storage and retrieval strategies. Labor management. SAP EWM enables the maximization of labor resources by overseeing and controlling worker activities, output, and productivity. It allows for planning labor times and resources effectively, calculating efficiency by comparing planned and actual durations. Cross-docking. This integrated solution allows incoming goods to be immediately forwarded to outgoing deliveries without the need for intermediate storage, improving the flow of goods. Value-added services. SAP EWM manages services performed in the warehouse beyond standard picking and packing, such as labeling, assembly, and kitting. It supports scenarios like kit to stock, kit to order, and reverse kitting. Yard management. It monitors truck entries and exits, gate occupancy, availability, and parking space management, optimizing logistics processes in the yard. 3. SAP EWM design and organizational structure. The SAP EWM structure is designed hierarchically, providing a detailed, granular view of the warehouse operations from a high level down to the smallest storage unit. Warehouse number. This is the highest level in the warehouse structure and manages the entire physical warehouse. It can manage several storage facilities that collectively form the complete warehouse structure, such as goods receipt areas, goods issue areas, high rack shelves, bulk storage, and activity areas. In SAP ERP, a warehouse number is typically a 3-character code, while in EWM, it's a 4-character code with a mapping between them for integration. Storage type. A storage type represents an individual warehouse facility or a physical/logical subdivision within the warehouse where products are stored. It consists of one or more storage bins. Examples include fixed bin storage, high rack storage, bulk storage, and open storage. Key indicators in storage type configuration. When configuring a storage type, crucial decisions include whether a handling unit is mandatory if addition to stock, allowing new stock into a bin that already has stock, is permitted, and whether mixed storage, allowing more than one product in a bin, is allowed. These settings significantly impact space utilization and operational efficiency. Storage type roles. Specific roles are assigned to storage types to define their function, such as staging areas, role I or D, work centers role I or Y, doors role F, yard role G, or production supply areas role K. Storage section. This is a subdivision of a storage type used to group storage bins with similar attributes for processes like put away. For instance, a high rack storage area might be divided into sections for slow-moving and fast-moving items. Storage bin. The smallest unit in the warehouse, representing the exact physical position where a product is located. Storage bins have attributes such as maximum weight, capacity, and bin type, e.g., small or large pallets. Bins can be defined using attributes like aisle, stack, and level. EWM allows for mass creation of bins through tools like the bin structure in configuration. Quant. A quant represents the quantity of materials in a storage bin and is used for inventory management. It records details such as quant identification, number, batch number, stock category type, stock category, and stock usage. Quants are created and deleted through goods movements, and their quantity can be increased by adding stock to existing quants. Activity area. A new structure element in EWM, not present in WM. An activity area is a logical grouping of storage bins based on warehouse activities. It can encompass a single bin, a group of bins, or even concatenated bins from several storage types. Activity areas provide flexibility in work allocation and help create dedicated zones for personnel. They are mandatory master data, as many controls and settings that were previously at the storage type level in WM have moved to the activity area level in EWM. Generic versus specific activity areas. For activities like put away, replenishment, or internal stock changes, a single generic activity area often covers the entire storage type. However, for activities like picking, where work allocation and travel paths are crucial, specific activity areas can be created by grouping bins or aisles for dedicated pickers. Sorting of bins. Bins within an activity area are assigned a sequence number to optimize travel paths for pickers. This sorting can be system-generated, standard sorting based on predefined criteria like aisle, stack, and level, or custom uploaded via Excel for non-standard sequences. Custom sorting is typically used for complex warehouses or specific racks to ensure efficient picking sequences. Door. A door is a designated area where goods arrive at or leave the warehouse. Doors can be configured for inbound, outbound, or both directions. They are used to control put-away and stock removal processes, often having a default staging area assigned to them. Staging area. Staging areas are intermediate areas located near doors that organize the flow of goods. For goods receipt, they serve as interim storage for unloaded goods until put-away, and for goods issue, they hold picked goods until loading. The concept involves a staging area group, the storage type, a staging area, the storage section, and a staging bay, the storage bin. Stock is registered in the system upon unloading or goods receipt in the staging area. Work center. A work center is a unit in the warehouse where value-added activities like packing, deconsolidation, counting, or quality inspection are performed. Work centers are assigned to a storage type and can include settings for printing and allowed/disallowed packing activities. 4. Configuration and implementation of SAP EWM. Configuring SAP EWM involves a structured approach, starting with defining warehouse processes and setting up the organizational structure, followed by system integration. Warehouse process types. WPT, the warehouse process type, is a fundamental concept in SAP EWM, central to defining how warehouse tasks are executed. It is structured around 6 key configuration areas. Warehouse process type definition. This includes defining crucial settings like process categories, priorities, and warehouse order rules that drive efficient execution of inbound, outbound, and internal warehouse tasks. Control parameters for put-away and stock removal. These settings govern how goods are placed into or retrieved from storage bins. Settings for storage process. This defines complex processes for handling goods, potentially incorporating multiple steps. Settings for change configuration. Controls how changes to warehouse tasks are managed. Settings for production supply. Manages material supply to production. Settings for warehouse request. Defines how warehouse requests are handled. Process categories. WPTs define the type of logistical operation. Common categories include put away, PTWI, movement of stock from staging to storage bins. Stock removal, picking process for outbound deliveries or consumption. Internal warehouse movement, INTL, stock transfers within the warehouse. Posting change, STCH, updating stock attributes without physical movement. Cross-line stock put away, CLSP, manages consolidated put away for multiple delivery lines/handling units. Physical inventory, INV, facilitates inventory counting. Replenishment, REPL, initiates stock replenishment for picking areas. Warehouse order creation rule, WO rule, defines how warehouse tasks are bundled into executable warehouse orders, controlling grouping based on activity, quantity, or weight. Initial organizational structure configuration. Creating foundational units. This involves creating the company code, plant, and storage locations. Plants are typically copied from standard SAP templates. Storage locations are assigned to a combination of plant and storage location, which is then uniquely assigned to a warehouse. ERP and EWM warehouse numbers. While physically there is one warehouse, in SAP EWM it is represented by a 4-character code mapped to a 3-character ERP warehouse code used in ERP documents like deliveries. Business partner creation. Plants must be set up as customers and vendors, business partners, in the system. This is mandatory for integration and stock identification, especially in scenarios like stock transfer orders, STO, or consignment processes. Specific roles, e.g. FLCU01, FLVN01, are assigned to these business partners. Copying standard configurations. For storage types, doors, staging areas, and work centers, standard templates provided by SAP, e.g. Y-Series ones, are typically copied and then adapted to specific business requirements. BC sets. SAP provides business configuration, BC, sets which contain basic settings for best practices. These are implemented by the basis team with functional support to activate standard configurations for EWM. System integration configuration. Seamless communication. The goal is to establish seamless communication for data flow between ERP and EWM. In SAP S/4HANA, embedded EWM, master data is automatically synchronized, eliminating the need for IDOCS or CIF for master data, as it is a single system instance. However, for transactional data, deliveries created in ERP are still replicated to EWM, and subsequent goods receipts or posting changes in EWM update ERP, behaving like 2 distinct systems. Basis settings. Key basis settings for integration include logical systems, identifying ERP and EWM logical systems. RFC destinations, setting up remote function call, RFC destinations for communication, which are dummy in embedded S/4HANA but were crucial for connecting separate instances in decentralized EWM. Queue schedulers, SMQS, SMQR, SMQ1. These transactions manage queues for data transfer between systems. They control connection times, runtime errors, and retry mechanisms for failed queues due to locks or other issues. Business system group and business system. A business system group is used for master data integration, while a business system is used for transactional data. In a decentralized setup, one EWM system could connect to multiple ERP systems using business system groups to identify the origin of master data without relying on volatile logical system names. In embedded EWM, typically one business system group and one business system are used, often aligning with the ERP system. Warehouse assignment in LE. The warehouse number from logistics execution, LE, needs to be mapped to the 4-character EWM warehouse number. Storage location to availability group mapping. Storage locations are mapped to availability groups in EWM. This allows EWM to identify stock from different storage locations as separate entities, crucial for distinct inventory tracking. Supply chain unit, SCU/SCUs, are SCM objects used to store address and time zone information for the warehouse, as EWM warehouse configuration itself doesn't hold this data. Shipping points from ERP are represented as SCUs with good receiving office and shipping office attributes on the EWM side. Planning locations are also assigned to SCUs. Party entitled to dispose, custodian, and owner. These are business partners used for stock identification in EWM. Party entitled to dispose, the organization responsible for planning and making decisions for the stock, often the plant. Custodian, the party physically storing the stock, could be the plant itself or a third-party logistics provider like DHL. Owner, the party with legal ownership of the stock, crucial for scenarios like vendor consignment, where the vendor is recorded as the owner. Acknowledge advanced functions. Companies must explicitly acknowledge if they are using advanced EWM functionalities, e.g., slotting, waves, MFS, labor management, kitting, yard appointment scheduling, as these often require an additional license beyond the basic S/4HANA Enterprise license. Distribution model. A specific transaction is run to activate the baddies, business add-ins, necessary for distributing transactional data, such as deliveries, from ERP to EWM. Without this, deliveries will not be replicated to EWM. Workforce management, labor management. Labor management in EWM monitors and evaluates warehouse employees. It uses formulas defined in LMF transaction and conditions defined in LMC transaction to calculate planned duration for activities, often based on parameters like wait. The system tracks actual execution duration and calculates efficiency by comparing planned and actual times. This data can even be used to adjust future planning of engineered labor standards. 5. Integration with other SAP modules and external systems. SAP EWM is designed for deep integration within the SAP ecosystem and with external systems, ensuring seamless business operations. SAP S/4HANA. Since the introduction of S/4HANA, EWM has been integrated into the core of the business suite, known as Embedded EWM. This provides a unified system with real-time data processing and a common database, eliminating the need for separate interfaces and duplications between logistics and commercial users. SAP ERP, ECC 6.0 for older SAP ERP systems like ECC 6.0, SAP EWM operates as a decentralized system add-on, separate from the ERP instance. Data exchange for master data, e.g. customer, material, vendor, typically uses core interface, CIF, while transactional data, e.g. inbound/outbound delivery documents, uses IDOCs or queued remote function calls, RFC. Business Application Programming Interfaces, BAPIs, are also used for accessing business processes. This separation was traditionally to distribute workload and prevent performance impairment. Other SAP SCM applications. EWM is integrated with other SAP SCM applications, such as for slotting and availability checks. Automation systems. SAP EWM has interfaces to numerous third-party automation systems, including automatic storage and retrieval systems, AS/RS, autonomous industrial trucks, and forklift guidance systems, enabling smooth integration and warehouse control. Non-SAP ERPs. EWM is designed as a standalone, independent module capable of connecting to non-SAP ERP systems. Mobile devices/RF. SAP EWM has robust capabilities for connecting with mobile radio terminals, RF devices, supporting real-time, bidirectional communication, and data recording via barcodes for increased efficiency in the warehouse. 6. Benefits and advantages of SAP EWM. Implementing SAP EWM offers numerous advantages that translate into significant operational improvements for businesses. Increased productivity and efficiency. SAP EWM streamlines warehouse processes like receiving, put away, picking, packing, and shipping, significantly boosting operational efficiency. Features like wave management and task interleaving reduce idle time and increase throughput. It has been shown to reduce warehouse lead times by 30% and increase productivity by 15%. Improved inventory accuracy and control. It provides real-time insight into goods locations, movements, and levels, facilitating precise inventory management and reducing errors. This helps prevent stockouts and overstocking. Optimal resource utilization. EWM enables the effective use of warehouse resources, including space, manpower, and equipment, by optimizing storage placements, slotting, and dynamically allocating tasks. Increase precision and adherence. Automated workflows and system-guided activities minimize errors, improving order fulfillment accuracy and ensuring adherence to industry standards and legal obligations through traceability. Adaptability and scalability. EWM offers scalable functionality that can be adapted to evolving business needs, supporting operations of any size and complexity, from small depots to large, complex warehouses. Seamless integration. Its strong integration capabilities with SAP ERP, S/4HANA, and other SAP modules provide a unified view of operations and streamline end-to-end business processes. Improved reporting and visibility. EWM offers extensive reporting and monitoring capabilities, providing real-time insights and data on operational metrics and KPIs, which enhances decision-making and fosters continuous improvement. Support for complex procedures. It is designed to handle complex warehouse scenarios, including cross-docking, value-added services, yard management, and multi-level storage control. Future-proof solution. The transition from SAP WM to EWM is becoming unavoidable, making EWM a future-proof solution for companies undergoing rapid growth, dealing with inefficient processes, or building new logistics centers. It aligns with the principles of Logistics 4.0. 7. Conclusion. SAP EWM stands as a comprehensive and highly flexible system designed to manage and streamline complex warehouse operations. Its robust features, from precise inventory management and labor optimization to seamless integration capabilities and support for advanced functionalities, empower organizations to achieve significant improvements in productivity, accuracy, and resource utilization. By enabling real-time visibility and adaptability to changing business environments, SAP EWM is an indispensable tool in modern supply chain and logistics management, helping businesses meet evolving customer demands and make informed decisions effectively. That's it. Join the 10 minutes for supply chain membership. Inside, you'll unlock members-only deep dive videos on procurement, logistics, and strategy. Weekly global updates that keep you smarter than your competition. Exclusive case studies and templates used by real industry pros. Live Q&A sessions where I answer your questions in real time. Plus early access to videos and bonus discounts on our resources. Click the join button now and become part of the smartest supply chain community on YouTube. Thanks for watching, and as always, stay informed. Stay ahead. Stay supply smart.